Okay, I almost forgot to start recording. So real quick, related rates. First thing you're looking for is rates of change with respect to time. We can tell this is respect to time because of the per second. We are asked how fast is the radius of the balloon increasing while air is being pumped in. That implies some time change going on. So what I do is I look at, they gave me this rate of change. The units help me to see that this is a rate of change of volume. So this is telling me dV dt. Every time you write down a rate of change with respect to time, you need to figure out if it's a positive or a negative number. And whatever thing is that this is saying changes with respect to time, what you're really looking for is that thing increasing in its quantity or decreasing in its quantity? If air is being pumped into a spherical balloon, do you see that volume is increasing? Plus, they kind of said it. So always, though, take the time to check if it is a positive or a negative based on whether it is growing or shrinking. So positive 100 cubic centimeters per second. There are no other rates given. So now I need to look for what is the rate of change they're asking me to find, and that is the radius of the balloon. So I'm going to write down dr dt equals question mark. And this is where I always start related rates, is figure out what the rates of change with respect to time are. Then I'm going to highlight the V and the R, because your goal is to get an equation that is not involving rates at all, but an equation that says how volume and radius are related. Then when you implicitly differentiate with respect to time, that will give you a relationship of the rates dV dt and dr dt. So you're looking for, you want to relate the rates by taking the derivative implicitly. Now, the AP test never expects you to know some of these volume formulas, with the exception of, say, a rectangular prism. So maybe you remember, maybe you don't, but you would be given that the volume of a sphere is 4/3 pi r cubed. And let me add on that related rates problems are often the most ridiculous questions because they are about things that would never happen. Would you have a perfectly spherical balloon? I suppose maybe nowadays I've seen them a little more, but whatever. The latter problem is a good joke coming up. It's quite amusing. But know that a lot of the related rates problems are like, that wouldn't happen. Oh, like a kite is flying horizontally as you let out string. That's one of the types of problems that they give. It's just absurd. Anyway, I'll be quiet on that. So step 2 that I described, and I'm going to bring that back up. Step 1 was determine all the rates with respect to time that the problem gives you and asks you to find. I just did that. Now determine an equation that uses all the variables, but only those variables. Doesn't have extra. And I have a little note of don't use the when information. Do you see how it says when the diameter is 50 centimeters? That's what I call when information. So you have a radius of this balloon that will be changing as time progresses, a volume that will be changing as time progresses. If I put in the information that the diameter is 50, so meaning radius is 25, if I plug that in right now, the whole problem is messed up, because I have to first get the rates related to each other before I can put in specific numbers because it's going to want you to get that relationship, and then for a particular moment determine how fast something is changing. But don't put that moment stuff in until you have the derivative. So here we go. We have number 2 done. This is now step 3. Step 3 is differentiate implicitly with respect to time. So for volume, taking the derivative of v with respect to t is just dv dt. Constant multiple times, and then realize you have r is a baby function. So far we've done implicit differentiation where we had y's and x's and we were going with respect to x. Now, nobody is with respect to the variable we are differentiating. They are all babies. So, blah cubed, derivative is 3 blah squared. Give mommy her baby, multiply by derivative of baby with respect to time. As soon as you've done that, the problem's almost done. It's a matter of plug and chug. And that's step 4 is just plug in the information. Now you can now you can put in the when. So we were given dv dt is equal to positive 100. We are supposed to find dr dt. And we have one thing left to plug into. If the diameter is 50 for the when information, that means the radius is 25 centimeters. And to save time, I'm just going to go to the answer. But at this point, it's just a matter of arithmetic. And actually, would it be okay if I just said, I'm taking all these examples from your textbook. You can open up that textbook. Well, I'm sorry, you can download that textbook. Not necessarily open. And look up the final answer yourself. Is that okay? All right. That way we can get more problems in. Now, the infamous ladder problem. Oh my gosh, this is so not realistic. All right, I'm going to draw a picture. Come on. A ladder rests against a vertical wall. This is a 10-foot long ladder. The bottom of the ladder is sliding away from the wall. So that means the bottom of the ladder is touching the ground. So I've got a hopefully perpendicular ground to a vertical wall. The assumption is it is. And this is moving away from the wall at a rate of exactly and precisely 1 foot per second. They want you to determine how fast the top of the ladder is sliding down the wall. And that's a question mark. And then the when information. I'm going to underline the when information and then not use it until the very end. Now, when you are about to make an equation, you need a variable for everything that is changing. So you're going to make up whatever variable you so desire. And I'm just going to go ahead and throw in my own choices so that we can keep going. This length of the triangle formed by the ladder, I'm going to let that be x since it's horizontal. When they are telling us that the bottom of the ladder is sliding away from the wall at a certain rate, x is going to grow. So dx dt is going to be positive because x is growing 1 foot per second. Then they're asking how fast the ladder is sliding down the wall. The ladder will slide down the wall at the same rate of change as this distance is changing. I'm going to put a variable y on that one. We need to find dy dt. The reason they like the ladder problems is because they can give you a right triangle with a side that is constant. However ridiculous the problem may be from there. Now, right triangles are one of the main diagrams that show up in related rates. If there are no angles involved, Pythagorean theorem is your go-to. If angles are involved in rates of change, you're going to pick a trig function. It's going to be like either sine, cosine, tangent, or actually any of the 6. And we will be seeing those. Any examples I don't get through today, we're going to continue talking about these on Monday. And I kept the angle rates out for the weekend so that we could talk about them more on Monday. So you need an equation that relates x and y before taking the derivative with respect to time. And can you see Pythagorean theorem just screaming? So what I've done so far is step 1 with what I wrote down. Step 2 is recognition of x squared plus y squared equals and plugging in constant 10 for the hypotenuse. That's step 2 done. Now I need to take the derivative with respect to time. And x is not time, y is not time. Those are both baby functions. So I'm going to take the derivative with respect to time. I first have blah squared. Power rule says derivative is 2 blah. Chain rule says give mommy her baby and multiply by the derivative of the baby with respect to time. Then I separately differentiate when I hit a sum. And I have blah squared. So again, 2 times blah. Chain rule says give mommy her baby, multiply by derivative of baby with respect to time. And then be careful, that is a constant. Can't tell you how many times people have accidentally put 2 times 100 on, or 2 times 10 on a test and then cried afterward. Okay, now that is step 3. Step 4 is a plug and chug situation. I have been given dx dt, so I can plug in there a positive 1. From there, my when information is when the bottom of the ladder is 6 feet from the wall. That's referring to this horizontal distance. So I now have a number to plug into that x. Now, they didn't specifically give me y, but if they don't specifically give you something in here, it's because they gave you enough information to find it. So look at that triangle. If you've got 2 out of 3 sides, bring old Pythag up. And anyone notice the special right triangle ratio anyway? Woohoo! Yes. The side length is 8 because of a 3-4-5 ratio. So at that point, your job is to just do the arithmetic to isolate dy dt. Now, important about how you answer the question. This asked how fast is the top of the ladder sliding down the wall. It's asking for a speed. But when you answer the question, you want to say it is sliding down the wall at a rate, and you need to give a positive number. You're going to get a negative rate here because y is a shrinking quantity. When you answer meaning of problems on the AP test, they like it when you use words increasing and decreasing. Be aware if you use the word decreasing because you have a negative rate of change, make sure you say decreasing and give the positive number. So that's a little thing to watch out for. I will let you look at the answers in the textbook from there, and I'm going to move to example 3. The infamous water tank. And it is an inverted circular cone. They need to do inverted circular cones at times because there's a special geometry property that they expect you to recognize. Now, For starters, let's read the problem. By the way, in geometry, technically, actually, do you guys know that a cone technically is what you would consider two cones? It's the whole. Anyway, so when they talk about a cone in geometry, they're referring to just this one. So that's why they call it inverted. Don't worry about it from there. All right. The base radius is 2 meters of the tank. The height of the tank is 4 meters. They're telling you that water is being pumped into the tank. So we are creating a cone of water. For that cone of water, it is increasing its volume with respect to time. It is increasing by 2 cubic meters per minute. They want us to find the rate at which the water level is rising. So rising would imply vertical. They want us to find how quickly this H of the water cone is changing. I like to put a question mark. You'll organize your information however you like to organize it, but you do need to organize it. These are the only rates of change that I have been given or asked to find. On the AP test, you will not be expected to conjure up a memory of volume of a cone, but I'm really hoping that you can conjure it up by remembering that a circular cylinder is area of a circle times height, so pi r squared times height, and that your cones and pyramids always have a ratio to their, why can't I remember words right now? But anyway, they're cylinders and prisms in a 1:3 ratio. Maybe you remember, maybe you don't. AP test will give you this formula. Very important, very important. You have a rate of change for volume and you are finding a rate of change for height. You are not given any information about the rate of change of radius. Let me point out to you that while volume is changing and height is changing, that radius is changing too. That R is not a constant. What do you do when there's an extra variable that you don't know a rate information about and you're not asked to find it and you're stuck with it? If you want to save your time, you're going to first find a relationship that variable has to other variables that you are given rates for. That is going to be your fastest way through the problem. So now, conjuring up of an old geometry property. If you have a cone and you slice it with a plane parallel to the base of the cone, you create a smaller cone that is, vocabulary word, this is my blank, that is blank to the original cone. And I'm waiting for a vocabulary word there in chat. Similar. Woo! Yes. So if you have these three-dimensional objects are similar to each other, what do you know about their one-dimensional dimensions? Each set of, they are proportional. There you go. So what that means is you can set up R is to H as 2 is to 4. If you like, you can reduce it to 1/2 immediately, whatever. But this gives me a relationship where I can find R in terms of H, and I can then use that to plug into the R. And that's the key to when you have more variables in your equation than you are supposed to be working with based on the rates with respect to time. So here we go. We're plugging it in. V equals 1/3 pi times 1/2 h squared. And I'm going to go ahead and just do the squaring. And then realize that what you have is a constant multiple pi over 12 times h cubed. It is worth the time to do that simplifying. Now I have only the v and the h. Now I'm ready for step 3 of take the derivative with respect to time. So I'm going to ddt both sides of the equation. On the left side, derivative of volume with respect to time is the derivative of volume with respect to time. Pi over 12 is a constant multiple. And then blah cubed. Derivative of blah cubed is 3 blah squared. Give mommy her baby, multiply by derivative of baby with respect to time, and you are now ready for the plug and chug step. So, what information were we given? And by the way, there's that when information that you don't plug in until the very end. So when the water is 3 meters deep, that would be H. And dV/dt is 2 cubic meters per minute. At that point, you can isolate dH/dt. The answer is in your textbook, and I'm going to move on to the next problem to go through as many examples with you as I can. All right. I'm going to move on, and I am recording this, so you can look back and pause this later. My next problem. Oh my goodness. I had to keep... I had to bring the diagram with this because I, for some reason, have an issue with directions. Which way is east and west? Yeah. So, car A is traveling west at 50 miles per hour. Car B is traveling north at 60 miles per hour. Both are headed for the intersection of two roads. Could you imagine reading this without a diagram? I've noticed the AP test is pretty good about giving a diagram if it's needed. They would give you this diagram. Said they are both headed to point C. Now, realize they just gave you two rates of change. And I want to talk a bit about the difference between positive and negative with rates of change with this problem. So they're saying that X is the distance between car A and the intersection at C. If X represents a distance and you look at this motion, is dx dt positive or negative? It is negative because X is shrinking. The distance X is shrinking. And it's going to shrink at a rate of 50 miles per hour, the speed that that car is going. Now, variable Y. Do you see that as car B travels north, that distance Y is shrinking? Does everyone see that? Distance Y is shrinking. That means dy dt is a negative rate of change. It is negative 60. And I want to point out also to you while this is moving up, when we're dealing with velocity, moving up means positive velocity. You need to realize that we are not looking at velocity. We are looking at making sure we are clear what our variables are actually representing. Be very clear about what it represents, and pretty much you're dealing with positive, I don't want to say objects, but like distances, volumes, radius. These are things that are positive. If they're negative, we have problems. So you want to actually be thinking about just whether who is being represented by that variable is growing or shrinking in its quantity, in its amount. All right, so we have two rates of change we are given this time, and that's different from the previous problems, which is why I wanted to at least get through this problem before class was over. Now, also, trying to read the wording of this is just hideous. This asks, at what rate are the cars approaching each other? And then the when. Oh, I highlighted the when. I don't want to highlight the when. Come on, do what I want. Now, what I highlighted in blue, you might have to read that a few times to figure out what it's talking about. It's asking what is the rate at which the cars are approaching each other. The cars are located here and here. So if we're talking about them approaching each other, what would we connect between those 2 points to say distance between them? Straight line. So when they say, what is the rate at which the cars are approaching each other, they're actually meaning what is the rate of change of the distance between them? So we are being asked to find dz dt. Now, this time we have 3 variables involved. We need all 3 of them in our equation when we set it up. Anybody see the right triangle? Feel a little bit of Pythagorean coming in? So Pythagorean theorem gives me x squared plus y squared equals z squared. If this is a problem in multiple choice, you can solve this however quickly you can solve it. You're just trying to get a right answer. I say that for a reason. If you're in free response, you have to show them the calculus work. You cannot show them geometry work. Let me be clear about that. If it is in a free response section, they are expecting calculus work, not geometry work. Because there is a geometry way to do this. So I'm making sure to say if it's multiple choice, sure, use whatever. Now, I'm basically done with step 2. That's what this equation is. And now I'm ready to differentiate with respect to time. And each of these x, y, and z variables, none of them are time. So they are all implicitly differentiated. Here we go. Blah squared derivative is 2 blah. Give mommy her baby, multiply by the derivative of the baby with respect to time. Plus derivative of blah squared again is 2 blah. Give mommy her baby, multiply by derivative of baby with respect to time. And finally, we're on to taking the derivative of z squared with respect to t. So it's blah squared, derivative is 2 blah. Give mommy her baby and multiply by derivative of baby with respect to time. And voila, you have an equation that relates the rates, thus related rates. Okay, now what information do we have? we were given dx dt and dy dt. And from there, we're supposed to find dz dt. That means I still have yet to figure out what is x, y, and z. This is when I hit the when information. The when information tells me when car A is 0.3 miles away from the intersection, and when car B is 0.4 miles away from the intersection. Anyone feel a 3, 4, 5 coming on? Now, you have to know variable z, what its value is at this moment. They didn't give it to you because you can find it with Pythagorean theorem. So you're just going to pop in that this is 0.3. Excuse me. You're going to pop in that this y is 0.4. And then through Pythagorean theorem or your knowledge of 3, 4, 5, find z and plug it in, do the arithmetic, and then you finally get an answer. Now, dz dt is going to give you a negative number, and it should. If you look at this diagram, z is shrinking. However, how do you write the answer with words? You want to say the cars are approaching each other at the rate and then give the positive answer of dz dt. Does that make sense? Okay, I am very happy because I managed to get through the first 4 examples before time ran out, and I actually still have a little bit of time. So I can go ahead and start example 5 with you. I'm debating whether I have the time to do it. No, I've been going pretty quick. Or maybe I should just wait. I'll wait, go over it on Monday. And then I'm just going to present again. I have this attached into your homework. It's not an assignment. It's just if you need to be walked through a problem. I've got an entire walkthrough based on step 1, 2, 3, and 4 on a problem that I did not assign from the homework. And I'm going to say again, Khan Academy, this is a time to use them. I'm not going to assign you anything. You're going to assign yourself Khan Academy because you have a test on Friday. This weekend is your only weekend to practice related rates. I heavily, highly, tremendously advise you to go on there and start working through their problems. They give it as types of problems. It's one of the best things I've seen on Khan Academy in prepping you for a particular idea. Okay? All right, then I'm going to stop the recording.